filling in a data sheet is you need to know what to fill in on a data sheet. The most important thing on valves and on flows is to wrap your mind around what you're busy with. And that I'll guide you through. It's not just walking in there and say, I'm going to fill in a data sheet for a data sheet. I've got the process data, now I can carry on, I can just fill it in. That's what David and Lars and those guys are struggling with. They get a data sheet saying, I want a valve. What bloody valve? I wish I had examples of data sheets that they've received in their lives, where they have to supply a valve with no information whatsoever. So with that behind us, you'll see my presentation is not on the board, because every time a presenter walks up here, it takes 5 minutes and people say, can I get a copy of the presentation? Now here's a copy of the presentation, just give to the gentleman. So you already have a copy of the presentation, and then you can make notes as you carry on, which you normally can't do. First of all is the documentation that you need before you can start thinking about a data sheet. The first one is you need an MFD to see what is the purpose of this valve, what's it going to do. Immediately from the MFD you can see, well, it's a 6-inch line, it is a control valve, it's not an on-off valve. Immediately you can see what's the purpose of the valve and what's the function of it. The next thing you need is the process data to tell you all the information that you need to size the valve and to request the valve. And the other thing in Sassol's case is the SIL calculation. Once you've gone out on an RFQ and you didn't put on the SIL and you then want to add the SIL, you will go out for an RFQ again. Because the price difference between a SIL valve and a normal valve can be astronomical. So those are the things you need even before you look at filling in a data sheet. Then we can go to the items that you need to check. First of all is the fluid type, and there I come to wrapping your mind around what you're doing. Anybody can fill in a data sheet, but to know what you're filling in is quite different. It's a different world. Is it a gas, or is it steam, or is it liquid? The moment you say gas, you say noise. Gas makes noise if your differential is too high. When you see liquids, you say, I'm looking at cavitation. I must immediately look at my pressure drop. These things you must know even before you touch a pen or a computer to fill in a data sheet. Find out what you're dealing with. We'll get to the other stuff that's also, okay, just the next one. Confirm the process. Now I know it's a gas. What type of gas is it? Is it oxygen? The moment you say oxygen, you say, oh, the material of the valve, the internals, is it Monel? Is it stainless steel? The body, is it carbon steel? Is it stainless steel? Is it Monel? The example of the valve that I gave you at the back, you can have a look at the materials of construction. The internals and the body will be Monel. And Monel is very, very expensive. So if you have all of this in your mind and you start with a data sheet, you know you're dealing with a very expensive valve. And you must go and find out, do I need Monel? Do I need stainless steel? That is not shown on your process data sheet. If you go out on an RFQ just saying it's oxygen, they don't know about it. They don't know the Sassol requirements. Within ESCOM and those places, you can go and put in a carbon steel valve. Nobody will twink an eye. I can show you how many valves we've got in Sassol that is carbon steel with normal stainless steel internals. You will not do it anymore in Sassol. It'll now be Monel internals, and if the velocity is quite high, you'll also have a Monel body. So know what you're dealing with. Otherwise, you're going to go out on quotation, you're going to get a carbon steel quote, you're going to present it to the people, you're going to give a budget of a carbon steel valve, you estimate 150,000 rand for the valve, you end up with 1.4 million. Who's going to give you that difference? You told them, I'll put in the valve at 150,000 bucks. Now it's 1.5 million. 10 times the price that you quoted for. Who's going to pay that other 9 times? It's going to come out of your pocket. Your boss is going to say, you said I can put in a valve of 150,000. Where's that valve? Bring it. And let the client accept it. So before you start with a data sheet, wrap your mind around the application you're busy working with. Flow is exactly the same thing. We're not talking flow tonight, but Whatever you say here about a valve, you can carry over to flow. Know what you're dealing with. Don't think I'm the expert, I know everything that I need to do. Because you're going to put a price on the table. And that goes for the sill as well. You didn't say it's Monell, you didn't say it's a sill valve. Now all of a sudden there's sill requirements which doubles your price. And then there's Monell and those which triples the price. Who's going to pay the difference? Not me. I'm not willing to do it. So confirm the process data. If you see cryogenic service, you immediately think sharp impact testing. If you go cryogenic, you have to do sharp impact testing. You have to specify, you have to tell Ross and David, I want sharp impact testing done on this. You can't go back to them later on and say, but now I want sharp impact testing. Because once you do sharp impact testing, when they cast the valve, they will cast your valve they will cast the whole body for you. But on that flange, they'll cast an extra piece. That's the piece they cut off and do the sharp impact testing. That's part of the casting. They can do the testing on that and then say, yes, this was sharp impact tested and it passed the test. If you didn't do it up front and the valve is here, they cannot cut a piece of this out anywhere to now go and do your sharp impact testing. I had the application before. They had to go back, get two bodies of the same casting with the same heat number. They had to destroy the one body. I had to pay for it. They had to destroy this body to get a sample, test it, and then certify the other body according to that. So if you do not put in your requirements up front, somebody's going to pay for it. And it won't be your client. Because you told the client, I'll charge you 150,000 bucks, give you that valve. I'll go and buy it for you and I'll put it in. You will still put it in, but you'll pay the difference. Because he wants a Monell body, sharp impact tested, according to his requirements. What you should have given as the expert and the specialist. Because you must tell, I'm a big boy, as Johan said, I know what I'm talking about. So if I want to say I know what I'm talking about, those are the kind of things you must think up front before you even start filling in a data sheet. So I'm not here to tell you, you must fill in a data sheet and you put this there and you put that there. I've learned you nothing. You haven't learned how to fill in a data sheet. You fill in a data sheet by first finding out what the hell am I dealing with. If you don't know what you're dealing with, don't fill in a data sheet. Because you're going to put your name at the end of that. You'll see all over. The guy signs for it, he says, I take responsibility. Once you put your signature there, you'll pay for it. Ask me, I've done it. Also on cryogenic service, on top of your valve you normally have your bonnet where your actuator goes on, fits on. Now on that bonnet, once it's cryogenic service, you might have to go for an extended bonnet. Some of it have cooling fins on steam, you might find some cooling fins on it. All those kind of things you must know up front to tell the supplier, I want an extended bonnet, I want cooling fins. Don't fill it in yet, scratch it here on the side. Oh yeah, it's cryogenic service, extended bonnet, sharp impact testing. All those things you must jot down on the side. I must check that once I start filling in my precious data sheet. Not just fill it in, I must know what I'm filling in. I'm still coming down, there's a lot of, I can carry on for a week as Johan said. Then also oxygen service, I'm using oxygen because that's where the most requirements are. This valve will be cleaned for oxygen service at the factory. It will be checked by black light. Once you put a black light on there, you can see any oil. If there's oil, you're going to have an explosion. Oil and oxygen don't mix, they explode. They don't like each other, none at all. So you must immediately on your notes put clean for oxygen service. If you don't put it there and it comes here, you will send it away at a hell of a cost to have it clean for oxygen service. Because they have to strip your whole valve, take out all the internals and then clean it for oxygen service. He didn't quote for it, now you want it. You didn't ask for it. He's not going to pay for it, I'm going to pay for it. I've already spoken about the material. If you're working with oxygen or steam again, you're sitting with chlorides. So you must know what material you need in your valve before you spec it. You can't expect the supplier to give you everything that you want. You must tell him what you want. You're the expert. You know what you want. Tell him what you want. If he doesn't give you an extended bonnet, he's quoted for another extended bonnet, but you want one. Ask for one. Then he'll price it for it. Now we come to the confirmation of the process data. Once again, don't just take the process data and say, this man is a process man, he knows what he's talking about. When he puts density down there, and it's oil, can it be higher than 1,000 kilograms per cubic meter? No. Oil is lighter than water. It floats on water. It will always be lower than 1,000 kilograms per cubic meter because it's lighter than water. You must know it. The moment you see 1,200, you say it's not oil, or it's a very precious oil. It's heavier than water. That you have to know it. You have to feel it. You have to see it. And you have to have that reference. Viscosity. What's the viscosity of water? 0.1 centipoise. Oil is less viscous. It has less resistance against movement. So if the viscosity of oil is bigger than 0.1, it's not oil. It is very resistant to movement. So once you get your process data, the man can make a slip up. Not everybody is perfect, not even me, I've tried. But nobody's perfect. Even he can make a slip up. And by he puts 0.01 for water. And you must then tell him, you must phone him and say, are you sure this is 0.01? Is this polished water that's non-resistant, or what type of water is it? It's like one day we had an Israeli boss, and he was busy with interviews with graduates. And he was busy in this conference room for the whole day. And he was trying to find out from them, what's the SG of water? As a simple question. I mean, everybody should know it. And he was coming out of the conference room as I walked by. And he asked me, what's the bloody SG of water? He was fed up by that time. And I said, what kind of water are you talking about? You're talking salt water? You're talking normal water? You're talking polished water? Because the SG of water is 1. Because SG, everybody should know that, is equal to the density of your fluid, of your liquid, divided by the density of water. So, if it's water divided by water, it's 1. But I asked him, what kind of water? Is it salt water? Is it polished water? Is it normal water? And he just walked off. He didn't speak to me for a week. Okay, but that's why I say, don't just accept the process data. Ask Mike Walsh, he's very facetious. He is pestering process guys on a daily basis for a week long on the same topic to find out the correct process data. And that's very important. If you take that, Mike, just one meeting please. If you just trust the man and you put on the wrong information and you get the wrong valve, the onus is on you. You checked all your information, you made sure that the information you got is correct. So if you start using the wrong information, that's why I say it's easy to fill in the data sheet. Take the wrong information, put it on there, put it out, get the wrong valve, who pays for it? It's very easy, I love it. So confirm your process data. The first thing you want to know is the pressure drop. As I said in the beginning, if it's gas, you're going to have noise if the pressure drop is too high. If it's a liquid, you're going to have cavitation. So confirm your inlet and outlet pressures. From that you get your pressure drop. Make sure you have the right temperature. And then the maximum flow rate. I just want to stop there for a moment. Somewhere Johan mentioned about the zero flow, or zero pressure drop, or zero pressure. They ask you for the flow, max, minimum, and normal. Now, they give you the maximum flow, it's 1000. Your normal flow is 800. Normally they give you a naught here. You want to know which is the minimum flow at which you still want controllability. You still want this valve to operate. No valve can control at 0 flow. So the process man must give you the flow, minimum flow, at which point you still want controllability. So let's say it's 400. Now we come to the next thing, and that is your inlet pressure. Now normally what people do is they say, oh, it's maximum pressure. No, they want your pressure at maximum flow. Maximum flow, your valve is wide open, so your inlet pressure drops. So you will find that this might be 600, this will then be 700, and this will be 800, because at minimum flow your valve is more closed, you have a higher back pressure. So your pressure at minimum flow will be higher. Same with your pressure drop. At maximum flow, your valve is fully open, you have a very low drop over your valve, you have a wide opening. So what you'll find is here, it'll be 50 kPa. At normal flow it will be 60 kPa, and then at minimum flow, because the valve is closed, you have a high back pressure and you have a very small downstream pressure. So your pressure drop is much higher, and this is where you normally pick up your problems with cavitation and noise and those kind of things. If a valve is fully open, it's not likely to cavitate or have high noise. It's normally as it starts closing down and your pressure drop increases. That's when you pick up problems. So here you'll find it might be 100. But if it's 0, it'll be maximum pressure drop. Because it's closed, there's no flow, you have maximum pressure drop. Right, and then your temperature. Then I've got it all mixed up, gas or liquids. You need density, that's for liquids. Viscosity, gas or liquid. Compressibility, normally for gases, because liquid is 1. Liquids are incompressible. You cannot compress a liquid, that's why they use it for hydraulics and those kind of things. Mole mass, that is for your gases. Specific heat ratio, Cp over Cv. That is on gases, that's your specific, the BTUs. Vapor pressure, and that's on a liquid. That's where you get your cavitation from. The moment you dip below your... I'm not here to present valves, please. I don't want to get into that too deep. I'll leave that for the experts that come later. Vapor pressure is on liquids. If you dip below your vapor pressure, that's when you get flashing and you get cavitation if it returns. If it stays below your vapor pressure, it just flashes. You can do nothing about that. Instead of just flash it into an open space or places where it can't damage you. But you can do nothing about flashing. Then we come down, you confirm your line size, as I said in the beginning with the MFD. You can immediately see your line number, you can immediately see your application. Is it an inventory valve? Is it a on-off valve? Is it a control valve? Is it a pressure control valve? Is it a flow control valve? Is it a level control valve? Because that again is where it comes in your equal percentage or your linear valve. On levels and pressures, it's normally linear. On your flow valves, it's normally equal percentage. And you have to know that. Before you fill in, if you don't know these things, don't fill in a control valve data sheet. Don't try to. You're putting yourself at danger. Because you're going to fill in that data sheet, you're going to send it out, you're going to buy the valve, you're going to take responsibility. So if you don't know how to fill in a control valve data sheet, don't fill it in. Because you are putting yourself at risk. And you're going to pay the price at the end of the day. The Sasol guys, they're fortunate. Sasol's got a lot of money, they just fix it. They pay it. When you're working for a private company, you pay for it. Or they'll get somehow to punish you for it. But you bought the valve, you know what you're talking about. You filled in the data sheet, you took the responsibility. So be very, very careful. Confirm the line material. With the Sasol guys, it's normally very easy. If you see the line number, you see A, you know it's carbon steel. If you see CRB, you know it's 316 stainless steel, or 304 stainless steel, or 321 stainless steel. Just by looking at the line class. N is again carbon steel, but now That's also a danger. It can be carbon steel or standardized, normalized carbon steel. If the line is normalized, your valve will be normalized. They do the normalized carbon steel for specific applications, not just for the fun of it. So know what material you need for the body, because this normally determines what your body material is. If the line is stainless steel, don't put in the carbon steel valve. If the line is carbon steel, think very carefully before you put in the stainless steel. You can, but then you have to put in isolation, insulation kits and all those kind of things so that the carbon steel and the stainless steel don't touch each other. In different materials, they just start rusting. You can even see stainless steel rusting when you put in different materials together. So again, think very carefully before you choose the material for your body. Confirm the area classification. That comes in with your solenoid and your positioner. If you need ATEX and IA certification, you have to certify it on there. Otherwise, later on when you come to you say, I want IA certification and ATEX. He says $800 a piece. Go and fetch the $800 a piece. It's $1,600. Go and get it from the boss. If you didn't specify it and you didn't quote for it, you're going to pay for it. They do that. Ask me. They do it to me regularly. Sometimes they're very good to me. Confirm the leakage rate. On normal valves, normal control valves, since they're just controlling, they're not dead for tight shut off or anything, you normally go for a class 4. And that's the lowest you'll find in Sasol, is a class 4 valve. Many times people call a class 5 a tight shut off. Class 5 is not a tight shut off. Class 6 is a tight shut off. Class 5 is very close to tight shut off. But if they say tight shut off, it will be class 6. And again, the price difference between a class 4 and a class 6 can also be astronomical at times, because there's special attention that needs to be given to valves like this. What most people try to do is they give you a soft seat, because with a soft seat you can get class 6 very easily. Soft seats are not allowed within Sasol unless you get a concession, and that is not easily granted, because the spec says very clearly no soft seats. Like they say, no mechanical stops. Don't put in a mechanical stop to keep the valve open or prevent it from opening too far. You're not allowed to do it. Confirm whether it's fail open, fail close. Some of the actuators you can easily swing it by just changing the spring. Put the spring on top and let the air go in on the top. You've got your diaphragm and you've got your spring. So if you put your air in there, it's going to close it. So this is a fail open valve. When you take your air away, the spring will push it open. So the spring will push it open. Now by just putting the spring on top and you put the air at the bottom, you have a failed closed valve. The moment you take the air away, the spring on top will push it closed. Many cases you can do that, but in some cases you order an actuator, fail open or fail close. If you specify it wrongly and you now want another actuator, you're going to replace the actuator. Who's going to pay for it? You. So make sure that you know. Yes, John.
Sorry, David. I think it's just important to mention that you get failure on the valve on both on air, on pneumatics, and on signal.
Yeah. Okay. I didn't capture that. I just said the failure action. But they always. I haven't seen it differently. It's I don't know whether you've seen it.
Many years ago at gasification.
That's a strange one. I don't know how you. Of course, normally they're the same. It's good, but okay. As Johan says, on the data sheet you'll find they ask you what's the failure on air loss, and then at the bottom they ask you, okay, here's the air failure, and then on top they ask you power failure. Now those are normally the same. That's normally the same, but as you say, it can differ, but that is very unlikely situations. So thanks for mentioning that one. But the most important is, make sure you know what your failure action should be. Then confirm your design and pressure and temperature. Because again, this valve must be certified to operate in your design conditions. If you say the maximum design condition is 100,000 kPa, this body must handle 100,000 kPa. And then he must immediately pick up. You specify a 300-pound body. No ways the 300 pound is going to handle 100,000 kPa. No chance. So then make sure that your design pressure and temperature is on there, and then immediately you look, what body rating did I specify? Did I specify 300 pound or 600 pound? And if you're not sure, you go to the line class again. Because the line class, in the little line class book, will tell you immediately. For a class A it's 150 pound. But within Sasol you will not use 150 pound valve. They're all 300 pound minimum. It's a 300 pound minimum valve. But if it goes above 300 pound, you must immediately also say, it cannot be a design pressure of 100,000 kPa because it's a line class A, which is specified as 150 pound. It's low temperature, low pressure. Then you can query them and say, sorry, you say your design pressure is that, but it's a line class A. How do you get it right? It is not possible. You cannot get those design conditions on a line class A. It should be for hydrogen or one of those high pressure applications. But that's, again, you must know what you're talking about when you fill in a data sheet. Don't just fill it in and say, I can fill in a control valve data sheet. It doesn't work. You're going to pay for it because you put your signature down there. Then confirm the valve characteristic, as I said now. Normally on pressure and level, you'll find that it's linear, and on flows, normally it's equal percentage. But confirm that, and what do the people want? Many flow valves are linear because of the process. Then on the actuator, ensure that you specify the maximum delta P that you want this actuator to work on. If your pressure drop is 100 kPa, do not specify I want this at 80 kPa. The valve, what the valve must handle is at least your upstream pressure. So that if your valve is fully closed, you can open that valve against that differential. So take your inlet pressure, your maximum inlet pressure, and as a minimum, use that as your differential for your actuator to operate on. Mike, just one meeting please, thanks. Ensure that the maximum channel pressure is higher than the maximum pressure. To ensure that the actuator is sized to handle the maximum DP. Then you do the valve calculation. Now, you have all of this now. Mike, again, one. Again, when you do it, now you have enough information to do your valve calculation. You have now looked at the type of fluid, you have looked at the differentials, you've looked at the flows, you've got all the information you need to do a valve calculation. Then do the valve calculation. Now you can see, do I have cavitation? Do I have noise? What kind of valve do I need for this application? To test for yourself. There his responsibility comes in. You've given him all the dope that he needs. And if he can't size a valve according to that, he takes the responsibility. If he delivers a valve and you can prove that he didn't size it correctly, the onus is on him. He gave you the wrong valve. So you can stand up in court and say, gentlemen, this is what I give. Get me a guy that can size a valve, and if he sized the valve that I should have got, then he didn't size it correctly. But if you give him the wrong information, and he sizes according to the wrong information, and he supplies according to the wrong information, you've got no leg to stand on. But if you give him all the correct information, and he gives you the wrong valve. That's why you do your own calculation. You do the calculation, you check, you see there's cavitation. Now he offers you a valve and he doesn't offer you an anti-cav valve. You can immediately say, sorry, no, there's something wrong. You can phone him and say, did you really size this correctly? According to me, I've got cavitation. According to you, you don't have cavitation. Now an anti-cav seat and trim and things can cost you a lot of money. So do your calculation and then correlate and make sure that what he's offering you is exactly what you should get. Check the percentage opening at the different conditions against the specification. Okay, I'm talking here Sasol, but if you look at Eskom and all those people, they might have different conditions. So at your maximum flow, they might say that at maximum flow, your valve must be 80% as a minimum, not smaller than 80%. So you have good controllability. I'm not saying that's what the spec says, I'm giving examples. I'm not a spec expert. And then at 50%, at normal flow, they say between 60 and 40. And then at minimal flow, it must at least be 30% open. Nobody wants to control right on the seat. So check that your minimum flow is at about 30%. Check that. Confirm, yes, this valve can do. It's not always possible. You might find that the valve will be 90% open here due to the process conditions, which I definitely want to do. And here it will be 10%. It is quite possible. And you cannot get another valve. If you want to do this differently, then you put in two valves in series and control through the two valves. If you want to spec, straight to the spec on the letter. But in some cases you get this and then you talk to the people, Francois Ebers, those guys, you say, this is my situation. What do you propose? Should we put in two valves or can we handle this? Is this only at normal conditions that I get this? So yes, it's normally a bit lower, but they can go up to 100% and you must control it. So that you have to check. Check the sound pressure level. And that is for gases. Make sure your noise is below 85 dBA in Sasol. Sasol says all valves, the noise level will be below 85 dBs. Confirm the body type and size for the application. Body type normally comes in if it's an on-off valve. Many places they say you will use a trunnion mount ball valve. Make sure that you specify, I want a ball valve. If you want the ball valve, tell him, I will only accept the ball valve. If you don't put in there what valve you want, he's going to offer you what he can get off the tail. What he has got available in his arsenal. If you want the ball valve, tell him you want the ball valve. And it must be trunnion now. Or it can be floating, whatever. You tell him what you want, if you know what you want. But if it's any kind of valve, you can just leave it open. And say, you tell me what you can give me for this application. They're the experts, they know what kind of valve to give for what application. Julle sal seker like as al die data staat er so lekker vir jou presies sê wat jy wil. Some mal weer sal confirm the CV rating of the valve against the calculation. Once he gives you the offer, you check the CV that he's given against the one that you've calculated. Maybe you've miscalculated. Now you see there's a huge difference between his CV and my CV. And by the way, you can use any sizing program of any company. They should be very, very close. They will differ because he likes to be a bit different from Alpert. He doesn't want to use the Alpert calculation. Alpert doesn't want to use the Dresser one. They have their own little one. Nellis have their own little one. But they should be very, very close. CV is only calculated in one way, with a little bit of twitches from the suppliers. Because they say, my valve is better in this respect because it's got a CF of this. And that can twitch your CV a little bit. Double check again for noise and cavitation. When you have gas, immediately check whether you have noise. If you have liquids, immediately check whether you have cavitation. Because those are the kind of things that cost you money at the end of the day. Double check on these things. I can't emphasize it too much. Double check on it all the time. Confirm that it's flanged valves. I say they're in hazardous liquids, but as a standard install flanged valves, no wafer type valves. Butterflies, in many instances where it's water and it's the water plant, yes, use flangeless valves, but with permission. Talk to the guys and say, what do you normally use in this plant? They're all wafer types. Why come now with a flangeless valve? They're all 150 pounds. There are plants where you're allowed to put in 150 pounds because the whole plant is 150 pounds. But in the petrochemical industry, they're all 300 pound flanged.
Yeah.
And tell them you want the flanged valve. Otherwise, he's going to offer you a wafer type. It's cheaper. And he can win the bid by making it cheaper. Because within Sasol, it's price and delivery. The cheapest valve at the quickest time, even if it's plastic or polystyrene. So tell them what you want. Tell them what you want and you'll get what you're asking for. Otherwise, there's going to be a hell of a price difference and somebody's going to pay for it. Confirm the body and flange ratings. Again, you know the line class and the little spec book, the piping spec tells you exactly what it should be for that line class. That's what the line can handle, and that's what the design and design temperature and pressure will be around. The moment you see it's too high for a line class A, phone the guys and say, somebody made a mistake. Either the MFD is wrong, or my process data is wrong. Somewhere it doesn't tie up. A line class A cannot be a 600 pound. But you have to know that to fill it in. Body material against line class. But once again, you can have a CRB which is 304 stainless steel, but you're using a Manel body because it's oxygen. And the reason for the Manel is due to the high velocity of the pressure drop that you're having through the valve, forces you to use Manel instead of stainless steel. Make sure the actuator is spring return and not a piston. Sasol don't like piston valves, piston actuators, because what a piston is you have a diaphragm this side, diaphragm this side. You put air this side and it pushes at that side, you put air this side and it pushes at that side. And you've got a trunnion mount over here that turns it 90 degrees. They don't really like those kind of actuators on their big applications. On our valves and those kind of things, they normally use it. But as a standard, you will have spring return and not diaphragm, piston types. Confirm that the ATEX and IA certification is obtained, otherwise you're going to pay for it. They're going to charge you for it. Confirm that the positioner is smart type in Sasol. Again, there's many places where they say, no, I don't want the smart positioner, I want the E900 or whatever that I'm normally using in my plant. There's many guys that say that. They do not want the smart positioners. They still, like me, old school, give me the old positioner I can work on and I know. Talk to the client, but as a standard, you will use a smart positioner. Then, also a very important thing is, once you have a Sol rated valve, and it's an on-off valve, you need to find out whether you need partial stroking. What partial stroking does, is your valve, you've got your partial stroke in there, onto the actuator. Now this valve is sitting there for a year. It is a shut-off valve. It's not moving anywhere, because it's holding your process in for an emergency. When the emergency comes, you want to open this valve. It is now stuck in that position. All the moss and rust and everything. Now it's stuck there. It's supposed to work and it doesn't want to work. So what the partial stroking does is once a week, once a month, whichever time limit you put on there, it'll just give a small signal to this valve just to crack it. You can decide 5%, 10%, 20%, whatever the process can handle. But it just twitches the valve so that it cracks and it moves. So by the time that it needs to move, it will move. And that is what partial stroking is for. That's why you need to know your Sol rating, and you need to talk to the guys that's doing the configuration of things. Do we need partial stroking? But as a standard, when you have on a valve and it's a Sol rated valve, partial stroking will be included. If a solenoid is used, confirm the housing is explosion proof. In the olden days they used to use these small little groendoppies, which is non-sparking. It is not allowed anymore. You will not use non-sparking. The ones that's in there they keep, but if you do a project, it will be the large big cap explosion proof EXD. Then on a solenoid, confirm the voltage level. As a standard within Sasol, 115 volts. Sasolberg 24 volts. Some places within Sasol, 24 volts. Confirm the voltage, because if you order 115 volt, you're going to get 115 volts and not going to work. 24 volts doesn't work on 115. And definitely 115 doesn't work on 24. The coil turns red. You don't like it. And then confirm that the ATEX and IA certification for the solenoids obtained. You need one for the positioner, you need one for the solenoid valve. If limit switches are required, they must be normally open as a standard, fail safe. Your proxies must be, or your limit switches must be open, fail safe. So that if something happens, if you cut your wire or something, it will open. If something happens to the proxy, it must open. So that you can immediately see there's a fault. If it's normally closed and something goes wrong, you will not detect it. If the wires melt together or something like that. But as a standard, all limit switches are normally open. And then again, for the switches you need your ITEX and IA certification. So there's 3 certifications. One for your positioner, one for your solenoid, and one for your switch. Then on the notes, at the back of your data sheet, you always have notes. And that is very important. All the things you want to tell the supplier, which you cannot tell him on the data sheet, now's the time to tell him that. You will see that on the one that I attached, that is for an oxygen valve, there's a lot of requirements there, like low dB plates, all those kind of things, which you cannot fill in here. Note it there. Tell him I want 2 low dB plates, one with a CV of this and one with a CV of that, this size. There is the place to tell him. So, first of all, you tell him that he must comply to your specifications. SP 70-1. Tell him that there you will comply to these specifications. If he doesn't have it, he can obtain it. But he must comply to these specs. He cannot later on say in court, I didn't know the spec. I didn't know it was written in the spec. He must know the spec better than I do, because he's selling it. And he says there, I will confirm to these specifications. If he doesn't confirm, sorry pal, I know I didn't write it all in here, but it is in the spec. I do not repeat the spec here. So they know they have to converse themselves with the spec. If they hear Ref 10 is coming out, they must stand in front of the line. Before I can get it, they must have it. So that they can say, I can comply to spec number 10, Ref 10. I've read it and I can comply to it. And if you can't, then you must say, sorry, I cannot quote now, I haven't read your spec yet, I cannot comply. I do not know what the new requirements are. But if he accepts and he says, I can comply to Ref 10, and he doesn't comply, the onus is on him, not on me. Because I told him comply, he quoted and he said, I can comply, sorry, game over. Ensure you specify the SOL rating. Tell him here, my SOL rating is not applicable, or SOL 1 or SOL 2 or SOL 3. Ensure you stipulate the PER requirements, they must comply. For those who don't know PER, what normally happens is GAIN will import a compressor from Japan. And in Japan, the supplier manufactures that piece of equipment according to the PED, Pressure Equipment Directive. They say that my equipment is manufactured according to this, it can withstand these pressures, and yes, it is safe. What then happens, he gives it to GAIN. GAIN sells that to me. That thing blows up in my face. He tells me, go back to Japan. They made it, I've got no responsibility. What the PER states is that GAME will say, they will give you a PER in which they say, I take all the responsibilities of the PED. If you have a problem, come to me, don't go to Japan. I accept full responsibility. I believe that this guy did manufacture it according to PED. I flew over to Japan, I looked at the factory, I saw that they conform. If he wants to import a cheap imitation from Taiwan, and it does blow up in your face, GAME is responsible, not Japan. Ensure you get the face-to-face dimensions, because that's the first thing. You're sitting in a hazard study or a basic engineering meeting. What's the first thing the mechanical guys ask you? What's your face-to-face dimensions? I want to do my ISOs. You haven't even spec'd the valve yet. Where must you get the face-to-face? You're sitting in a normal meeting before the project has started off. What's your face-to-face dimensions? What's the weight of the valve? That's the first question they always ask. So make sure that once you've decided on a valve, that's the first thing you ask the supplier. What's your face-to-face dimensions? Because you must immediately give it through to the mechanical guys so they can carry on with their ISOs and allow for that space. And then all your other notes, clean for oxygen service. Make sure whatever you couldn't tell the man, which you know you should have told him, and you couldn't put it on the data sheet, tell him, yeah, now's your time. Sorry, I've spoken a lot, I've never given you a chance, now you've got chances for questions. Right, any questions? Nee, ik merk dat het stom gepraat. Sorry, no.
Just have it on that data sheet.
Yes.
On your solenoid valve.
Yes.
When you say when it de-energizes the valve vents.
Yes.
I normally see they say the valve opens or it closes.
Yeah, you'll find that everybody has got a different idea. What we say it vents your air from the valve. Now, if they say on what do they say? On power failure.
It opens.
The solenoid opens. When the solenoid, what does the solenoid do on power failure? The solenoid opens. Now when it opens, what does it do?
On power failure, you're saying the position open. So I expect that the valve opens, not the solenoid.
You expect. But what does it say there? What does the solenoid do on power failure? It vents. It vents your air off the actuator. When you say it opens or it closes, you mean the valve opens or closes. You've already said on power failure the valve opens or closes. Why say it again? What you say is on the solenoid it vents. And you can ask, Mike will have a different opinion, Lars will have a different opinion, you will have a different opinion. Johanna, Floyd, you have another opinion. What makes logical sense? You've already said that on power failure the valve will open or close. Now on power failure on the solenoid will vent. That's what it does. It vents, whoops.
Okay.
But I'm open to discussion on that. It's not, I can't tell you what to put there. And how do you understand it as a supplier? It vents, takes the air away. But you've already told him that this valve must fail on power failure and air failure. It must vent, must open or close. But as I say, it's open for interpretation.
What's the opposite of
this? You can say on a three-way, it's always vents. That's why you use the solenoid. You can, in cases where it's non-fail safe, you can say that locks or. Maar gewoonlik as hy in die energized position is, van instrumentasie is dit fail safe. Hy's ge-energized as die ding normaal opry. Nou wat gebeur as jy die krag verloor? Jy wil hê moet werk. Maar ek het nog nooit die situasie gehad dat hy toevuil of oopvuil, dat jy air wil deur hê as hy vuil. Op jou firewater wells kry jy dit wel. Dat wil hy moet oopvuil.
Ja, daar blyk nie wells.
You start working with the 40 way.
Yeah,
Not the
yeah.
50 way. Then you must.
Yeah, but then you have to tell him what you want the whole setup to do. And then you select the right solenoid. You tell him I want a 4-way double acting or a 5-way double acting, 3-way acting or whatever.
Flow directions. You can flow directions if possible.
Okay, flow directions, hoekom moes jy dit nou sê? As jy by vergassing kom, nou as hulle praat van flow direction, dan sê vergassing vir jou, die flow direction is left to right. Watter kant van 'n valve is links en watter kant van 'n valve is regs? Hang af watter kant jy van die valve staan. Nou sê hulle, die flow direction is left to right. Nou as ek so staan, dan sê ek, okay, die flow direction is so. Nou kom die fitter, nou staan hy aan die ander kant. Nou sê nee man, die flow direction is so. Dis left to right. Ek het nou al hoeveel argumente daaroor gehad, is jammer dis nie 'n vergassing oor vanaand. Ek wil hê iemand moet vir my verduidelik what does left to right mean? Can you explain to us? Depends where your positioner sits, but now they turn your actuator around.
Especially depending on the modifiers you're talking about, because they're not facing.
Yeah, the thing is, if you work there, then it makes sense to you. But to any other guy that works on a valve, now the one guy told me that it depends where the positioner is. You stand in front of the positioner, now that's left and that's right. Now the valve shop turned the actuator around, the positioner's on the other side. Now I've got a problem. The valve's going to be the wrong way around.
They should have turned it around. Depends if it's flow before they stood it. Depends if it's flow to open or flow to close.
Yeah. Flow to open, flow to close makes sense. It's flow over the plug or flow under the plug. It makes sense to everybody.
Okay, then you can see where the flow goes
Yes,
in and goes
yes.
out. Before you, so if there's a flow tend to open valve, you know where the flow goes in must go out.
Yeah. Because
So
normally,
it will tell you that.
yeah.
And then you can know how to install. Doesn't matter what they do with that, the actual.
Yeah. But then again, the rule of thumb. The rule of thumb is if it's a fail open valve, you want that flow tending to open. Because if the valve fails, you want the flow to assist the valve to open. So on a fail open valve, you normally say,
They're going to charge me for this paper as well, Brian.
But it's not a rule, right?
no, it's a rule of thumb. If they say nothing, you make the choice, you say fail to flow tending to open. But if the guy specifically wants a fail open valve to be flow tending to close, then he must tell you that.
And that makes a huge difference in the design.
Yes. Yes. But he must tell you that. The process man must say, I want this valve flow tending to open or flow tending to close. And they do put it on the process data sheet. But it's here they must change it. As a rule of thumb, if they say you make the decision, this is what makes logical sense. You want to, if the valve fails, the flow to assist you to open the valve. If it's a failed close valve, but again, that's open for discussion. That's my rule of thumb. Mike, you have another one? The same. Same thing. Everybody, but you'll find that everybody has different opinions. But this makes logical sense. If it's failed close, you want to force the plug down, flow tending to close, to assist you to make it close. Did you differ?
No, but there's a difference. If you're in Arab country,
Yes,
they
as I say,
read
it's open for
right to
discussion.
left.
Yeah.
So you must understand that. We're
Yeah.
in Africa. So it might be the
I'm
doctors.
in the world.
Yeah.
Why do you have it twice then? Why do you ask flow direction and then you ask flow tends to?
The day you find out, phone me immediately.
Yeah. It's because the front of the valve is always the cycle position. And for me to build your valve the right way to put it in your plant, I need to know, is it from the right to the left or left to the right? I need to know that. I need to know if it's vertical up or vertical down.
Yeah.
Because I need to know which way to put my
Yeah.
actuator. I need to know which way to put my actuator. So I need to know if it's left to right.
Yeah.
You should know which side when you design your plant.
So you want us to put there left to right or flow tending to open or flow tending to close?
Tell me. I want you to tell me
Yes.
that I went I went to my plant, and this is the best. I want to position on this side of the pipe and not on that side of the pipe.
Yes. But you want your flow direction this way, not that way.
With it, I need my flow direction, so like, there's flow tends to open, flow tends to close.
Yeah.
I give you a valve, and then you put it, that's why they always call me and say, please come and turn my actuator around.
Yeah, but
Because they
remember,
don't design correct, they don't know if it's left, right, right, left.
Yeah.
And when they come there, they put it in, they say, oh, but there's a pipe in the way here, I can't put it here.
yeah.
When they design the plant, they must tell me, it's left to right.
Ek sal nou weer jou kom opvolg want
That's-
ons kan tot môre
If the valve is in the, if there's a pipe in the way, so be it. You don't want a pipe in the way.
Now you can't stick to your original arrangement, left to right.
Flex and the can flex in the blood story on the sheet. You look at it and you decide what to use.
Yeah. Okay. Any other questions?
Yes.
Yes.